Hey, good evening, everybody. We're still in the midst of book writing, and we've got another fair day here in this part of Texas. A little bit of high cloud there, and looks like a little bit of maybe mid-cloud somewhere in there, maybe a little bit of altocumulus in there, about 15 to 17,000 feet up. And there's the pattern we're looking at right now. You can see that moisture coming into this part of Texas. There it is right there, some fairly dense moisture, and that's what we were seeing on the loop there. And it's pretty much the so-called Pineapple Express, bringing up moisture from the tropical latitudes of the Pacific. And you can see that a lot of the moisture is coming over the top of a ridge. You can see that northward bulge right there. That's going to be a large ridge running from northwest Mexico all the way up through the Central Rockies right there. And we're on the downhill side of that ridge right there on the east side. So typically what we get is that moisture drying out and subsiding on the lee side of that ridge. But there's so much moisture coming across it that that process really doesn't take place very effectively, so a lot of clouds coming over the backside. But in Arizona, they're pretty much at the end of that fire hose, and let's try taking a look at the scutees. Now, I did have some problems bringing up the University of Wyoming site. Sometimes it does this. I'll reload and I'll get this broken image, and I don't know what the problem is with their website. However, I do have a backup here. And let's see what we got going on. Flagstaff, they're going to be picking up some of that moisture. And you see right there in the upper part of the troposphere, moisture all the way from about 25,000 feet, about the 350 millibar level, all the way up to about 180 millibars. It's going to be up at about 43, probably about 43,000 feet there. So a pretty thick band of moisture. And if you're flying across Arizona, you're going to be in the middle of that cloud and just see a lot of gray through the window. And definitely plenty of winds up there, 100 knot flow. But beneath that, lots of dry air. So that's typically what we see when we have this band of moisture coming through from the tropics. It's mostly focused up there in the upper part of the troposphere. Tucson is showing a very similar picture, maybe the moisture a little bit lower, based at about 16,000 feet, and then extending up into the upper troposphere. We do have to keep in mind that even though it shows dry air up here, the radiosonde instruments have very limited ability to reliably detect relative humidity at these colder temperatures. So we do have to kind of take this with a little bit of a grain of salt. It could very well be dry up there, but there could also be moisture up in that part of the troposphere. And a good way to tell how the sensors are doing is to look at the stratosphere up here at the top. Typically, the stratosphere runs a relative humidity of about 10 to 15%. And I'm not too sure exactly what that works out to as far as dew point depression, but there should be at least be a pretty decent spread in there. So if you happen to see the moisture line running very close to the temperature line, that tells you that something is wrong right there, a problem with the sensor. So probably what we see here is very close to what we would expect for the stratosphere. Then on the other side of the ridge, looking at Fort Worth, of course, there's those double layers of moisture. Looks like the second layer, looks like it's probably based at about 21,000 feet or so, and probably another layer right there in the mid-levels. And below that, looks like we do have a little bit of higher relative humidity in the low levels, down below 10,000 feet, and a little bit of a subsidence inversion right there. And that's due to that subsidence on the east side of that ridge. So what we're doing is we're basically forcing a lot of this air down to lower levels, maybe from like here down to here, and when it does that, it's going to warm at the dry adiabatic rate. So that process is going to tend to spread the temperature off to the right side. So the bottom part is going to be pretty warm at the bottom of that subsidence column there. And we will also see dry air where that happens. And then down further beneath, that's going to be under the regime of tropical flow coming up from the Gulf. And we can get a better look at that from Corpus Christi. They've got easterly winds coming up off the Gulf there. Some fairly deep moisture there. Dew points on the order of upper 60s, dropping off to probably mid-40s up at about 6,000 feet, and then picking up some 40s once again up at about 10,000 feet. And then Lake Charles, showing a little bit of northerly flow there, and dew points in the 50s for the most part, with 40s all the way up to about 8,000 feet. And picking up a little bit of that subsidence right there too, and some very good dew point temperature spreads at about 10 to 15,000 feet. So the weather pattern right now, this is the isobars in thickness. Looks like our gradient is pretty much spread out. Our thickness gradient is pretty much spread north and south through much of the country, a very wide band there. So it looks like, yeah, we do have a front down in the southern U.S., but kind of a very weak temperature spread along that front, and most of the gradient extending well to the north. So I think what we're seeing here is probably the south part of that front all the way down in Mexico. And a lot of that spread in that thickness is due to high pressure. See, there's a big high right there covering the entire eastern U.S. all the way down to the Gulf, all the way out to the Atlantic, and all the way up north to Baffin Island. So this is under the influence of that big high. Also another high out in the Pacific covering this entire area. And then to the north of that, we've got a little bit of a storm system off the coast of British Columbia. So this area here is under the influence of this low. So the flow here is a little bit more cyclonic. And another low system in northern Manitoba right there. So this kind of gives you an idea of what's going on. We've got the temperature spreads moving apart in the eastern U.S. and out in the Pacific, and coming together out in the northwestern U.S. So we should see these thickness lines start to come together over time. So maybe a little bit of frontogenesis in the northwest U.S. Okay, and then elsewhere, it looks like we got a bit of a lee side trough from Colorado up to Wyoming. And this is kind of where I might be looking for a little bit of cyclogenesis or frontogenesis. I'm going to take a look at the SPC charts. And I'm going to see if we can look at the fields up there in the northwestern U.S. Yesterday we did look at a product called the tensor magnitude. I'm going to see if it happens to pick up that front, and I don't see any clear evidence of that. And just looking at the winds, they do look to be kind of homogeneous, kind of a southerly flow like that. And they do have a couple of frontogenesis products that's going to be in here somewhere. Let me see if I can find where that is. Yeah, frontogenesis. We want to go up to probably about 850 because 925, that's going to intersect the terrain. There's 850. And what this gives us a plot of is 850 millibar heights in black. See right there? So this is showing low pressure. Let me see if I can center this a little bit better. So showing low heights, low pressure up in Vancouver Island, and high pressure and high heights over Nevada down to the south. And in between, we've got a southwesterly gradient coming in off the Pacific and bringing in some moisture into the Washington and Oregon area. Another thing that we can see on here is isotherms. That's going to be the blue and red lines. See the dashed lines right here? That's going to be the isotherms. And this is showing that the temperature gradient appears to be a little bit further to the south. So maybe something like that right there. So that little front we were looking at up in the northwest U.S. looks to be a little bit further south. And then the purple lines right here, that's going to be our frontogenesis, and that's basically where we have a wind component pushing these isotherms closer and closer together. So obviously if we have a field, you've probably seen this in textbooks, where the streamlines look like this. You notice I have this kind of set up. I have this axis parallel to the isotherms. So what if the air is flowing like this, coming into, let me see if I can paint this. Yeah, say it's coming in like this into the system. And then up here it's coming in from the northeast, coming in like that, then blowing out this way. So how's this going to affect the thermal gradient? Well, coming into the system here and here, it looks like there's no definitive action on the isotherm gradient. But as we get closer to the center, we have the, let me see if I can bring up the colors. Yeah, there we go. We have movement away like this. So here we're spreading away the temperature contrasts. So that's not really conducive to building up that gradient. What we really need for that to happen, I'll draw this one more time. Let's try bringing in the air from the southeast and the northwest. So if we set it up like that, okay, now we've got a pattern that's conducive to frontogenesis. So you can see that the isotherms, if they're crossing the field like that, this is pushing them together. And that's going to build up the pressure, the thermal gradient. So the orientation of the wind field superimposed on the isotherms, that's going to kind of shape up what's going to happen with frontogenesis. So what that does is it evaluates that. It evaluates the wind field against the isotherms. So it does that for you and kind of shows you where that's going on. So this shows that, yeah, there's a little bit of frontogenesis taking place right there. So we would watch probably Idaho, maybe parts of eastern Oregon, and possibly down into California. So it looks like here, the wind field favoring isotherms coming closer together and possibly building that gradient. Let's go up to 700 millibars. Let's see, 700 millibar frontogenesis. Looks like a very similar pattern. The gradient a little bit further to the south, down in Nevada and Idaho. And we've also got layer frontogenesis. We could take a quick look at that. 850 to 700 is probably what's most appropriate for this mountain area. Don't see any real layer frontogenesis in there, but we do see what looks like an average of the temperature field. I think that's what that is. Let's see, we got radar, mean frontogenesis, and the temperature lines are not marked, but I'm going to assume that's probably a layer mean isotherm. Okay, another thing we can look at is, let's see here, 850 millibar plots. So this is showing the gradient a little bit. There's the thermal gradient off to the south. And down in Nevada, 15 degrees. They're at 5,000 feet MSL. That's going to be close to about 60 degrees Fahrenheit, so very warm air there in Nevada. And that contrasts very sharply with air that's close to freezing in Portland and Seattle. And with that air close to freezing, this is going to mean icing in this region right here. So we go up a little bit higher, 700 millibars up at 10,000 feet. We have minus 10. Lots of humidity in this area right here. So that's obviously going to create problems for flights coming into Vancouver and Seattle. Okay, here's a look at the frontal analysis. This is from Canada, so they're seeing a little bit different picture right here. They've got the fronts a little bit further west. So that's kind of what we have to do when we look at these charts. We have to kind of resolve these differences and try to figure out who's right. So is that front in that region like it's showing? Well, I might go back to this chart and do the surface observations. So what does this show here? Best thing to do is start off to the south. We know there's very warm air down in the Reno area, 60s. So we go a little bit further north, and we see 50s, 53 there. So looks like some mild air right in there, and probably some mild air all the way up into these valleys here of Washington. We've got 51 around Yakima, and I'm trying to remember what these cities are here. That's Yakima, PSC, I forgot what that is, Moses Lake. They've got a big Boeing test facility there when they're teaching foreign air crews how to fly their new 777s, 7087s. They fly them out of Seattle. They fly the planes to Moses Lake, and they do practice at that airfield right there. So it looks like pretty good weather. And it looks like the colder air is definitely, I don't know, it looks like maybe, let's see, we got 50s on the coast. This is really where we have to turn to the potential temperature. So yeah, this gives us a little bit different picture. So now we've got the temperatures corrected for mean sea level, and we're seeing a little bit different picture here. And I think that's going to put our gradient maybe somewhere in this area here. I definitely don't see any support for our front further west like that. There's no thermal field to support that. So most likely what's happened is we've got this chart here. You can see that, let's see here. Yeah, I can't seem to move this any further up, but it's showing 18Z. So probably what's happened here is this has moved east during the day, and now we've probably have got that over northern Nevada and Idaho. So now we're finding the front, something like that right there, and we can pick out the warm front there in Montana. We've got very warm temperatures here, around 70 in western Montana, and then there's our warm front. And it looks like that extends all the way down the Front Range. Okay, so we've got a pretty good analysis here, and back behind the warm front, this is the warm sector, and within that warm sector, we've got the tropical moisture coming over that ridge like that. And also we know that ridge extends from northwest Mexico up to Wyoming, and it's sitting right on top of this warm air. So that's that ridging, the upper level ridging gets there because of the very less dense air. It pushes the height surfaces apart from each other as you go up with height. And the result is high heights and high pressure aloft. So this is basically a big upper level ridge in this area here. And that's replacing this cooler air mass that we have over the central plains. And then out in the western U.S., remember, this is pretty much under high pressure, and you can see the light winds over this area right here. So this is the high over Ohio and Indiana and Michigan there. On the east side of that, we've got northerly flow. On the south side, we've got kind of a northeast flow, maybe coming east. And then on the west side, southerly flow. And it does look like that frontal boundary is backed way up out of the Gulf. We've got northeast flow out over the Gulf, and the front is well to the south, and then connecting back around to the west like that. Okay, so one thing we can do to kind of analyze that air mass, go back to the soundings. And we can pull up Wilmington. And that's going to be right there in near the Cincinnati area. And we can take a quick look at what it looks like in that high pressure area. This is 0Z, so this is about 2 hours ago. And there at Wilmington, we've got northerly flow. So this is going to be east of the high pressure area. If you look at the winds right there, northerly flow means the high pressure is off to the west. So that kind of orients you where you are in the air mass. And what we've got here is a very cold air mass. Steep lapse rate in the lowest 5,000 feet. That's indicating a lot of air mass modification, heating from below. The core of the cold air is up at about 5,000 feet right there. That's the cold air. And then above that, we've got kind of a subsidence inversion aloft. And probably, to a certain extent, that could be the top of the cold layer. I don't know, I kind of doubt that. I think probably the top of the cold air is actually way up near the tropopause, because this is pretty far north. The only way to really evaluate where that is to go to 850 and 925 and try to find the frontal boundary. Okay, so on the 925 millibar analysis, high pressure, and then down to the south, that front is well off into the Gulf of Mexico. So now we go up to 850, 5,000 feet. Where's the front? Looks like it's still out over the Gulf. And we can see cooler temperatures, -3 there at Wilmington, 2 Celsius, about 36 in Illinois. And we don't find any warm air until we get out into Texas. And there we have a little bit of downslope flow. Okay, 700 millibar. Where is the front? Looks like it's still to the south. We've got northeasterly flow right there in Florida. Very cool conditions across the eastern U.S. And we do have a little bit of warm air coming in off the Rockies. 9 Celsius there at Albuquerque. So I think probably here we're picking up a little bit of a warm front. And then that connects out into the Gulf kind of like this. It's probably a little bit even further south than that. But as we get out to the Great Basin area, that seems to happen a lot, doesn't it? Give me just a second. Area code 213. Is that California? I think that's probably a telemarketer. All right, so let's see, where were we? Great Basin area. You can definitely see a thermal gradient between Arizona and Washington. So you see the temperature gradient there. We go from 10 and 7 above to -8, -10. So I think we can definitely place a boundary from, let's see, maybe in this area here. So I'm going to go with something like that right there, kind of a stationary front. So this gives us an idea where the 700 millibar front is. So if we're analyzing skew-Ts around these areas, we can kind of figure out what air mass we're going to be at when we cut through the 700 millibar layer. So clearly in Ohio, we're going to be in that cold air at that level. So we're going to have to go south to find the frontal boundary. So let me go all the way down to Brownsville. And I don't find a frontal boundary down there. Let me try Miami. I'm looking for a signature that looks like a frontal inversion. Key West. Let me try Corpus Christi. Don't have a classic frontal inversion. Just going to take a look at a few soundings around here. And I think that a lot of the soundings here have been kind of worked over due to modification. So yeah, nothing distinct on any of these soundings. We're just seeing the air mass kind of respond and gradually warm with time there. So let's go up to 500 millibars, and now we're getting up a little bit higher, up to 18,000 feet. You can see that cold air over Ohio there. Warm air down to the south. And if we look at the gradient right here, it does look like there is one possibly in this area right there. See how the isotherms kind of come close to each other? So I think maybe we're looking maybe at a front, maybe somewhere in this area. Although it looks like this high pressure area, the subtropical high, that does kind of spread apart the gradient up there at that level. I think we do pick up the boundary maybe up in Nevada. This has kind of the look of a upper level 500 millibar front. So a lot closer here with those isotherms. And let me see what the conditions look like aloft. Does it rock in southern Nevada? And there's Reno. Looks like something going on right there, just below 500 millibars. So let's see, how does that compare? Reno would probably be on the south side of that signature. So now let me go up to the north. We'll go up to Medford, Oregon. That's going to be north of that little frontal boundary. And on this sounding, it just looks like the environment is getting cold. Nothing that looks like a frontal inversion there. Salem also looking very cold there. You can see how this line is way over to the left compared to the other soundings, which are way over here. And let me try a couple more soundings. This is Oakland, California. Can definitely see some tropical air all the way up to about 15,000 feet there. And then let me go down the coast to Vandenberg. Dry air. And the profile looks warm because we bring the lower part down dry adiabatically to the surface, and we've got temperatures there of 25 Celsius. That's close to 80 degrees. So this is a warm column there. So we know that the warm front, or the polar front, is going to be to the north of that. So let me go back up north to Oakland. Is this a warm or dry column? Bring that down dry adiabatically from about 850 maybe. That's about 70 Fahrenheit. That's kind of, it's a little bit on the warm side for San Francisco. And then Medford, bring that down dry adiabatically. And now we're looking at 50 Fahrenheit, so that's a lot cooler. And then Salem, again 50, so that's cold. And then Quileute, also 50 there. But the column, very steep lapse rate right there. And we go all the way up to Vancouver Island, and that tropopause, that's a sign that you're in that cold air when it's that low. That's down at about 32,000 feet. Compare that with Medford. It's a little bit higher, and compare that to Vandenberg tropopause all the way up at about 41,000. All right, so let's move on and start working our way towards the forecast. We can kind of take a look at the very turbulent weather there in the northwest U.S. There's the current chart, and that's showing southwesterly flow coming onshore. So we know that that surface front is down to the south. And we can see in the higher elevations we've got freezing conditions. We can see that white line kind of outlining the mountains. That's indicating a very steep lapse rate and the presence of cold air just off the surface. So yeah, this is all kind of a cold air mass. And to find that warm air, we've got to go further south. And let's see, the afternoon chart looking like that right there. Let's see, 54 at Tonopah this time of year, that's warm. And where I used to work back in the 90s was right there at Tonopah, and Vegas right down there, 64. That's a little bit warm. And Phoenix, 82 there. That's definitely warm. And do we see the typical northerly downslope flow, the kind of like the drainage winds from the Great Basin High? Do we see that? Well, definitely not. We've got kind of a light southerly flow through that region. So that's also signifying a warm pattern. And then the other pattern is going to be the San Joaquin Valley. You can look at that. And typically, if we're in a cold regime, we'll have northwesterly flow through that region. So what we have there is kind of a pattern like that right there. So that's suggesting warm air. And we got temperatures in the upper 60s and 70s there in the San Joaquin Valley. So definitely warm through that region. So the front located way up there. So let's look at quickly what happens out west over the next 36 hours or so. Just going to look at general changes, cold nights and warm days, and looks like we built up a little bit of a pressure gradient up north. That's probably signifying a change. Only down to 36 at night. That still sounds kind of warm. And then up to 60. Yeah, this is kind of a warm pattern all the way through the period. All right, let's head into the central U.S. and see what's happening there. Wow, 60s in Colorado. This is this afternoon. There's Lyman right there, and here's Denver. 67 there this afternoon. Wow. So it's been pretty warm, and you can see the lee side trough right there through Wyoming and into Denver. And ahead of the lee side trough, we've got southerly flow and downslope flow in the panhandles right there. So that's definitely moving out that cold air, and there's what's left of it there in Minnesota. Let's take a look at the forecast there very quickly. Tomorrow afternoon, lee side trough once again. Still got high pressure across the Midwest. And it looks like the troughing kind of extends like that right there. So it looks like we've got a little bit of high pressure moving into Wyoming and Montana. And then after that, we've got cold air spilling southeastward. And then by Wednesday, wow, look at that cold air coming into the central U.S. Cold front coming all the way into Oklahoma and Kansas very quickly. And we're looking at nighttime lows around the 20s and 30s. It's being moderated a little bit by the downslope component. And then daytime highs come up pretty quickly up to the 40s, so not particularly cold. Most of the cold air is going to be well up to the north. All right, we'll check out Texas here very quickly. We have ridging extending into the North Texas area right there. So cool air still coming down into East Texas, but out in the western part of Texas, we have southerly flow. So very warm in this part of Texas and kind of cool in northeast Texas right there. So for tonight, we fall to the 50s in northeast Texas and remaining pretty warm west of Dallas-Fort Worth. 60s tonight, and then tomorrow, very warm day. Mid-70s there in the Texas Panhandle. And then we get the cold front coming into Oklahoma and the Panhandles right there. And then by Wednesday night, that moves all the way down to almost to Dallas, and looks like it maybe stalls out a little bit. I don't know if that has enough steam to move any further south. The southeast U.S. under northerly flow right there, being dominated by that high pressure there up in the northeast U.S. And during the entire period, we've got northerly flow, so kind of a mild pattern there with lows in the 40s and 50s, and then highs coming up to the 60s and 70s. And then for the northeast U.S., that is, of course, dominated by the high pressure. Very cool weather out in Quebec and the New England area. And then just pretty much no change until we get late in the pattern. And then by Wednesday, the high moving off to the coastal areas, and then southerly flow coming up into the Midwest area. Okay, so we've covered a lot of ground there. Let's look at the infrared imagery, and let me check in on chat. Let's see, a little bit kind of a quiet evening. Not much weather, and of course we've taken long breaks, so it's not too active on chat. Ryan Toomey's here, another easterly, windy, rainy day in San Francisco. And David Moore is here, and Burl H. Thomas Copeland. We've got Dwayne Ward here, watching the replay, celebrating the old birthday. Mr. Manlet is here, and Ron Chalfant, another Southern California weather day. Sounds like it's probably kind of warm there. And let's see here. Let me scroll down quickly. The Hawkins EAS is joining us. Sue M. in Indiana there. Veo Joe, 42 degrees. Fun with Tech is with us, and Sue M. is still down with that flu, but fighting migraine. SBC wants to place a 15% risk of severe weather for Friday from northern Illinois through the Ozarks. Yeah, we'll take a look at that. Cloudy in DFW all day where David Moore is. 213 LA. Yeah, thanks. Thanks, Ryan. Mike R. Light rain falling across the San Francisco Bay Area. More wet weather for Wednesday. And bigger storm for the weekend. Mike R. mentioning atmospheric rivers set up this week. Could bring heavy rain to the burn areas of Northern California. So, yeah, let's hope so. Ryan anticipating that Caribbean system developing next week coming up. So, yeah, we're watching that. Yesterday, we saw that moving very slowly northward towards Jamaica. So we'll see if that has changed. And Ryan says in 6 hours, the JPSS-1 Polar Orbiter rocket is scheduled to be launched early in the morning. So, yeah, Vandenberg Air Force Base. So thanks for the news on that. Ron says, I love how Tim can blow through the charts. I get lost. Yeah. Well, it will come with practice, and of course you can get practice by watching the webcasts, and hopefully it'll gradually start sinking in. There is a little bit of repetition here with these weak weather patterns. So yeah, if you keep watching the webcast, you should get better at this very gradually. What do guys think about John L. Casey, the guy that uses sunspots to predict climate? Well, I'm not a climatologist, so I don't have too much of an opinion on this, but I don't see why sunspots wouldn't have an effect over the long term. That's certainly possible. It would not have any effect on the day-to-day weather. But yeah, solar cycles and issues with the orbit of the Earth, things like that, that can certainly have an effect there on the climate. And let's see, Andrew Hoffman watching the end of the live broadcast from Waxahachie. Okay, yeah, I'm taking a look at the chart here. Let's see, we had, how many viewers is that? We had 14 earlier, and we've kind of leveled off. The important thing is we've not had this plummet, so hopefully I haven't lost too many people there, and it looks like I haven't with that chart discussion we did earlier. All right, so let's head into the forecast, and we'll bring up the GFS. All right, there we go. All right, GFS here. Let's see, we've got, there we go, showing the high pressure there across the Midwest, and we've got the troughing over the Rockies, and also that storm system there over the Northwest U.S. So let's see how things go. We know that there's going to be that cold front developing in this area, and indeed we do see it. Remember, we were looking for that frontogenesis in this area, and indeed that does happen. And then that pushes into the plains around Wednesday. Wednesday is the big day that comes out. And then where's the warm front? That's indeed kind of a question, because you can see the thickness lines are pretty spread out, so that makes it pretty challenging. Well, I don't know. One thing we can do is we can look at the forecast SCUTs and just kind of see what that shows. So the bottom part of the temperature profile, yeah, see, that's showing a front-on version right there. So warm front, definitely down to the south of Illinois. So let's go down to maybe Fort Smith. Fort Smith. Yep, front on version right there at about 900 millibars. So we got to go all the way down to Dallas. Let's go down there. Okay, so now we break out of that frontal zone. Let me go in between. Let me go around Idabel. So this is a pretty handy feature, and there we do pick up the front-on version. And this can be actually very important if we're expecting severe weather. So yeah, it's not showing any features here. But obviously, if we've got maybe a short wave off to the west, this is going to be very important. Because if you're north of that warm front, in a situation like that, that can have a huge effect on the wind flow and the curvature in the hodograph there. So that will definitely locally enhance the storm. So we're looking at probably a warm front kind of like that right there. So we got to keep that in mind when we're working with these charts. And regardless of what the official forecasts say, this is absolutely a occluded front. And a lot of times I'll see, I bet you there's some forecast charts that have something like that. And that's because the forecasters will just, drop in what looks to be correct. And that's definitely erroneous. That's not what's happening. So you got to keep everything consistent with the three-dimensional picture you have of the atmosphere as you work with this. So this is the actual pattern here. And of course you could also have something like that. That's not out of the realm of possibility. Two distinct systems. So that could be what's happening there. So let's move forward. And that also means that this is kind of a baroclinic zone here. So we could see development of that coming together. Okay, so we'll move forward. Oh yeah, look at that. Some showers and storms coming together. That's going to be on Wednesday. Okay, high pressure moves in. There it is right there, pushing the cool air eastward. And then we have the southerly flow pick up in the high plains. So we look to the west once again. Probably something like that going on, and looks very showery there in California. And the isotherms are packed very closely together, the thickness lines. And I'm just going to kind of guess maybe the front is something like that. So it looks kind of active there, getting into Thursday and Friday. And look at the Sierra Nevada is developing some snow showers. That's probably a good sign that the front is pushing southward. Maybe something like that right there. And I think that's what's happening there in the plains. And then, I wonder if I have a black pen here. Let me see. Whoop, that's not it. Okay. Oh, you can type text. That's convenient. Okay. Anyway, I was looking for black. I guess I don't have the black color. All right, but that's what I would use for drawing that trough. So getting into Friday, let's see here. Okay, things get active in the Rockies and the Central Plains for Friday, and there it is. There's our system, and definitely right there over northern Arizona. Wow, look at that cold front coming through this area here. And possibly if we drop a sounding in, we can kind of see some of that structure. I dropped it north of the front, and we don't really see a frontal inversion there. What we see is more along the lines of a very steep lapse rate in the lower part of the atmosphere. So conditions out west can be a little bit different. So let me drop one. I would do area 51 maybe. So let me drop that right there. They're going to be back behind the cold front about now. So yeah, very steep lapse rate coming in there, and you can kind of see the backed winds. Actually, that would be kind of yeah, see how this kind of backs with height? It goes from northerly to westerly, and that's indicative of cold air advection in that layer. And then down south of the frontal boundary, down maybe around Flagstaff, let's check that out. A little bit different picture there. Let me try Phoenix. So this is firmly back in the warm air, and 73 there, kind of a warm pattern on the charts there, and there's the front. So let's see what happens during the day Friday. This is when we're looking at that severe weather possibility there. Yeah, see right here. That's going to be along the leading edge of that front as it comes southward. So now we've got ourselves a severe weather possibility. Let's check out the soundings out in the warm sector. And by warm sector, I mean, this is just kind of a preliminary guess where the fronts are. I'm talking about this area out here. So we're going to check out a couple of soundings out in this warm sector. Let's try Indiana. Looks to be kind of like a mild pattern here. Don't see a frontal inversion. However, there is lots of moisture there in the lower 100 millibars of the atmosphere. Let me go further south to Memphis. Got to keep in mind the time of day. This is midnight, so what might help is to back that up maybe to 0Z. Yeah, let's try looking at it here. Springfield, Illinois. Looks to be maybe up in the north of the warm front, possibly. Let's go down to southern Missouri. Looks to be just kind of like a cap there. 65 at the surface, and then East Texas. Trying to get a picture of what the warm sector looks like. 70. Let me go up to Paducah. 61. I don't see a very definite picture where that warm front is. I'm going to guess that that's probably all the warm sector from what I can tell. I think probably the warm front is up here. So let me go up to, let's see, let me go back here. Where are we at? All right, let me take this up to Michigan. And this is where I think we are going to see the frontal inversion. Yeah, there it is right there. And then we go south of Michigan into Illinois. Yeah, you see there's a much different picture there. So that's where the warm front is. It's right through here, Chicago, to Fort Wayne, and then into Columbus. So if we had the support for severe weather, maybe if things were moving a little bit slower, this is where I would expect some of the severe weather to be, right in there. But things are moving a little bit too fast for that. But there will be enough moisture to support storms along that warm front, but they will be kind of forced. So I'm not expecting too much severe with that. So that's going to blow rapidly through the Midwest and into the East Texas area Friday night. Lots of cold air advection coming in. And 540 line coming all the way down to Kansas City, down to Paducah, and all the way down to Charleston. So that's kind of like the freeze line right there, and cold conditions coming into the Great Lakes. And then for the rest of the weekend, looks like that. Very cold for the Northeast U.S. The Northeast U.S. has been getting cold weather for like about a year now, just constantly in the cold pattern while this area seems to bake constantly. I don't know what the deal is. But anyway, there it is. Things moderating in the central U.S., and then the next system comes in. Looks like Tuesday, maybe kind of a weak Alberta clipper. You can see the snow showers there around Minneapolis and northern Wisconsin. That moves rapidly southeastward. So that'll be kind of a reinforcing shot. 540 line coming all the way down to Memphis. And then looks like it'll be kind of quiet for a while. And then system comes across the northwestern U.S. and then shifts down southward. Something like that. And then we get to, yeah, there it is. There's our next system coming in. Looks like a little bit of an upper level low there. We could see some showers with that in the San Joaquin Valley, possibly a couple weak tornadoes back there. That tends to happen when we get these cutoff lows. And up in Nevada, snow showers up into Utah. So, yeah, that's going to be the next big weather change coming up. And, wow, look at that pop out there. Looks to be a very potent system and maybe a bit of severe weather in Oklahoma and Kansas along that warm front. Possibly to Missouri and Illinois. And looks like a little bit of maybe blizzard potential in western Kansas and eastern Colorado. So this is going to be the 29th into the 30th that we're talking about here. And that'll track up towards Illinois there. That's going to be kind of an interesting system. And cold air coming all the way into the central and southern plains. And possibly another shot. Looks like something coming together here in Nevada. So that could be another system that could come in for the first week of December. All right. We also have that tropical system out in the Caribbean. Let's check that out. I don't think I have any charts ready to go on this, so I'm just going to use the streamlines. And I think we may be looking at maybe this here. There's the 18th. Yeah, it looks like a different picture. Then I guess I'm going to have to switch over. Let me look at the sea level pressure analysis because it's got kind of a different picture there. Let's see. Let me scroll down. All right. Hopefully this doesn't mess up the stream too much. It's going to take about 30 seconds to load here. I guess we can start on that. What we see here, this is kind of interesting. This shows that cold front through this area right here. See how the winds are kind of strong out in the Gulf of Mexico. Down to the south, get far south enough, and we've got very light winds in the Caribbean. And you notice something else on this chart. Look at Mexico right here. Very strong winds. There's actually a mountain pass right in here. Okay, this is a mountain range. And this is a mountain range right there. And in between, we've got this mountain pass. And when we have a very strong cold front moving into that part of Mexico, we end up with these canyon winds on a large scale. And we've got, you can see here, winds gusting up to about 35 to 40 knots right there. So that's kind of a big factor this time of year. And there's an animation there of the winds. And they don't really subside until about Wednesday. So you can kind of use that as a barometer to what's happening as far as cold air advecting into Mexico and the southern Mexico area. So basically, fronts looking kind of like that right now, possibly even further south. Okay, then we pick up our tropical system. Yeah, there it goes right there. Spinning around out there in the Caribbean, moving very slowly. 10:08. I think there's been a very significant change to that forecast. Yeah, it's basically flip-flopped, and now we don't have a storm there. So we'll see that change again tomorrow. So let's check out what's happening elsewhere. I'm going to check out the Texas coast while I'm on this frame and see what happens. It looks like the Gulf is open, but we can see that this is all recycled air coming into Texas for later this week. And a lot of the moisture out in the Caribbean, that's being ruined by this very strong northerly flow coming in. Looks like our polar front is running something like that. So this is going to erode a lot of the moisture. So severe weather chances over the next week or so, I think, are going to be affected by that. And this has kind of the look of a barotropic system. And this looks like the next outbreak. See how that moves southward? This is Monday the 20th. And looks like the front stalls out, something like that. And then here comes our next outbreak. A couple of surges coming in, and then the gap winds pick up again in Mexico. And yeah, it looks like what Texas gets is mostly just recycled air, probably coming from the Atlantic. And yeah, that's probably about all I got for tonight. And let me see. Let me take one last look at the chat. Ryan says, like button, hit it hard. I appreciate that. And Kathy Campbell Wallace is with us. Hi, better late than never. Yeah, not a problem. And you can also play back the webcast once it posts, once the archive file is on there. Michael O is with us. Ryan is mentioning the European model had it in full detail. I guess we're talking about the tropical storm. And Ryan says we'll keep a watch on it. Can't take your eyes off Mother Nature for a second. Okay, I guess that'll do it for our webcast. Whoa. Okay. Getting a little bit of feedback there on the audio. Okay, well, that's about it for tonight. I hope you enjoyed the webcast, and we will see you tomorrow. Take care.